All right, in this lesson, we're going to look at how different graphs may represent some different real-life situations. So in this first graph, it is a graph that represents the path of a football as it is thrown in the air. I want you to pay attention to how the axes are labeled. Down here along the x-axis, we have time, and up here along the y-axis, we have height. So, I didn't really give you any numbers on here, but I think you can assume that time is passing here. So this is where I start throwing the football. This is actually how high the football is released at the ground, or at how high the football is off the ground when it is released. So I'm just going to write this. Height of football at release. All right, then in this section from here until I get up here, this blue section, what's happening in there is as time passes, the football gets higher. So the football is getting taller in the air. So seconds are passing and more time is going, and the ball continues to get higher and higher and higher and higher until I hit this peak up here. So as time passes, football gets higher. Okay? Then in this green section, what happens is now the football is starting to come down. The height of the football is decreasing in this section right here. So in that section, as time passes, football gets lower. Okay, until there's a key point that happens right here, and really anything to the left of this point over here or below this point over here is insignificant. It really doesn't matter in the situation. But at this point right here, what happens is the football hits the ground. Okay, and it can't go any lower than the ground, so that's all we need to worry about. All right, the next graph represents a puppy that is exploring a trail, and you have to pay attention again to how the axes are labeled. So the x-axis is labeled with time. This is the distance from the trailhead, how far away they are from the trailhead. So in this section right here, as time passes, the puppy is getting farther and farther away from the trailhead because the distance is increasing. So in this case, farther away from the trailhead. Okay. In this section, the puppy's distance from the trailhead is remaining stagnant. And if their distance from the trailhead is remaining stagnant, that probably means that the puppy is not moving. So I'm thinking right here that the puppy is stopped or is standing still because its distance is not getting closer or farther away. Okay. And then again, right here, the distance again is getting farther away from the trailhead. I'm going to do that. I color-coded it. And again, right here, the puppy is standing still, or the puppy is stopped, because that's what the green means. Okay. And then down here, in the blue section, something different is happening there. And in the blue section, what's happening is the puppy is getting, again, closer to the trailhead, so the puppy is probably walking back to the start. Okay. All right, then in the next one, we have someone who is jogging, and we want to look at their time, and we want to look at their speed. And so, here we go. This is as time passes. This is how fast the jogger is going. So what's happening in this section right here is the jogger is increasing its speed. Starts out slow, increasing their speed from here to here, right? The The same thing is happening right there. The jogger is increasing its speed as time goes by. Okay? So for me, the blue section means that the jogger is increasing its speed, getting faster. Okay? In these sections here, this one, and this one, and this one, the jogger's speed is remaining the same. So they're like warming up, getting faster, right? And then right here they sort of stop, and then they sprint again in that blue section, and then right here they don't stop, but their speed remains constant. Okay? So in the green section, speed remains constant. They're not getting slower or faster. And then, of course, in these sections right here, what's happening is the jogger is slowing down. Okay? All right, then this is a multiple choice one, which seems so easy, but it's really not. This is talking about a forest fire that grows slowly at first and then rapidly as the wind increases. After the firefighters answer the call, the fire grows slowly for a while, but then the firefighters contain the fire before extinguishing it. Which graph represents this situation? Okay. So you have to pay attention to what's on the x-axis and what's on the y-axis. Of course, we're talking about time. The y-axis, though, is the area that has been burned. Okay, so think about this. You have a forest fire. It is growing slowly at first. So what should happen is the area that is burned, because this forest fire is growing, should be at first slowly increasing. Okay, the area that's burned should be slowly increasing because the fire burns slowly. If we look at this graph over here, the area that is burned is not growing at all. It is remaining constant. And it says right here that it grows slowly at first. So the area that's burned should be growing slowly at first. It is growing slowly at first here, and it's also growing slowly at first here. But it is not growing slowly at first there. Okay, then as the wind increases, the firefighters answer the call. It does grow slowly for a while, which we can see in both graphs. We already pointed that out. And then the winds catch it, and obviously it goes crazy, right? And then it gets extinguished and whatever. Okay, but now think about this. What's on the y-axis is the area that has been burned by the fire. So let's think about this. Area that's been burned. So the fire is growing slowly, so the area that's burned should be growing slowly, and then the wind catches it, so the fire grows very rapidly, and the area that's burned is going to grow rapidly as well. And then the firefighters come and they slowly start to contain the fire, but think about this. This represents the area that has been burned. Once an area that has been burned is burned, can you ever take away that burned area? You can't, okay? Once it's been burned, it's burned. And the area that is burned can never, you can't take that away. You can't decrease that. So if the graph stopped right here, this could be it, but I can tell you the area that has been burned by the fire will never decrease. It's got to stay there. So this one makes more sense, okay? Starts off, this one's not right. Starts off slowly at first. The wind catches it, the fire grows rapidly, the area that's been burned grows rapidly. And then the firefighters start to contain the fire, and then it stops growing. But the area that's burned stops growing, but it will never decrease. It'll never get taken away. So that's why that situation is the right one. So C is the right answer in this case.